All right, let's just jump right in. We're about to try and crack the code on one of the most fascinating frontiers in AI right now. Building machines that don't just see or hear or read, but can actually understand the world by weaving all those things together. You know, a lot more like we do.
To really wrap our heads around this, let's forget about computers for just a second. Let's start with something totally human. So let me ask you a question. How do you really know when someone is being sarcastic? Think about that tone, right? Somebody says, "Oh, that's just great." How do you know what they actually mean? Exactly. It's not just the words, is it? Your brain almost instantly just fuses everything together. It takes the language, the what they said, and combines it with their tone of voice, the look on their face, their body language, the how they said it. And that combination creates a brand new meaning, one that didn't exist in the words alone or the tone alone.
So in the world of AI, there's a name for each of these channels. They're called modalities. You can just think of a modality as a stream of information. So, sight is one modality. Sound is another. Language is a third. And our brains? We are absolute pros at juggling all of them at the same time. So, here's the billion-dollar question for AI researchers. How in the world do we teach a machine to do that? To pull off that same incredible trick of perception? And look, this isn't just about making a cool party trick for a robot. Giving AI this superpower, well, that's the key to making AI that feels more intuitive, that's genuinely more helpful, more human-like. And this whole field of study has an official name.
Now, the official definition might sound a little academic, but stick with me, because there are two words in here that are absolutely crucial. They're the key to this whole puzzle: heterogeneous and interconnected. If you get these two words, you get the entire challenge.
All right, so let's break those two down, because once you understand them, you'll see exactly why this is so tough. First up, heterogeneous. All that really means is that the data is fundamentally different. Seriously, it's like trying to mix oil and water. The information from these different streams isn't just a little different, it's like they come from completely different planets. And this chart just lays it out perfectly. Just look at the difference between vision and language. For an image, the basic building block is a pixel, right? For a sentence, it's a word. Totally different things. The structure? An image is all about where things are in space. A sentence is all about grammar. And the density is worlds apart. You've got millions of pixels in a photo, but maybe just a dozen words in a sentence. Even the way they go wrong, a blurry photo versus a typo, is completely distinct.
Okay, so we've got these totally different types of data, oil and water. But, and this is the second key, for an AI to learn anything, there has to be a link. The data can't be totally random. There's got to be some shared thread, some common ground between them. And that, right there, is the interconnected piece of the puzzle.
And what's really cool is that this idea of interconnection kind of splits into two things. First, there's the connection. That's pretty straightforward. It's the shared idea. The word dog and a picture of a dog both point to, well, a dog. Simple enough. But then there's interaction, and this is where the magic really happens. Interaction is the new stuff that pops into existence only when you put the modalities together. Think back to our sarcasm example. That's pure interaction. So yeah, it's all about that interaction, where something new just emerges. You know what? There's a classic psychology experiment that shows this exact thing happening inside our own heads. It's pretty wild.
So, what happens when your brain sees one thing, but hears something completely different? This isn't just some riddle. It's a real phenomenon that psychologists have studied. And what our brains do? Well, it's probably not what you'd expect.
It's called the McGurk effect. So here's how it works. Your ears get one piece of data, an audio recording of someone saying ba ba ba. At the same time, your eyes get another piece of data, a silent video of someone mouthing fa fa fa. So, what do you actually hear? Your brain doesn't pick one or the other. It fuses them and perceives a third, completely new sound. Da da da. It's not ba, it's not fa. It's something your brain just invented. That's multimodal interaction happening live, right between your ears. And this quote just nails it. Something comes out of neither modalities, and you put them together and it comes off. That's the perfect description of this idea of emergence. It's when 1 + 1 doesn't equal 2, it equals something else entirely. For multimodal AI, this is the holy grail. An AI that gets this can understand nuance, context, and subtext.
Okay, so if that's the goal, to capture that magic of emergence, how are researchers actually trying to build it?
Well, they're basically working through a checklist of enormous challenges. This right here, this is basically the roadmap for the entire field. Just to pick out a few of the big ones, you've got representation. That's about how you take wildly different things like pixels and words and turn them into a common mathematical language the AI can even understand. Then there's alignment. This is about teaching the AI to connect the phrase golden retriever in a sentence directly to the exact pixels that make up the dog in the picture. And of course, there's generation, which you've definitely seen. This powers all the text-to-image models out there, where an AI creates something totally new in one modality, like a picture, from a prompt in another, like text. Every single one of these is a massive area of research.
And that really brings us to the big takeaway. The whole point of tackling all these incredibly hard problems isn't just to build a smarter AI. It's about building an AI that can be a better partner for us, for humanity, one that can collaborate with us on a much deeper, more intuitive level. So I'll leave you with this thought. What becomes possible when our technology can finally grasp not just what we say, but what we truly mean?